We begin with a simple physical setup involving a train and a tunnel. At rest, the train is longer than the tunnel, making it impossible for the entire train to be inside at once. But what happens when we approach the speed of light? Relativity offers a solution. Moving objects shrink. From the perspective of someone standing by the tunnel, the train, traveling near the speed of light, becomes shorter than the tunnel. This means we can, for an instant, trap the entire train inside. However, motion is relative. From the train's perspective, it is at rest, and the tunnel is moving backward at high speed. In this frame of reference, it is the tunnel that undergoes length contraction, while the train remains its proper, longer length. This creates a paradox. Both frames of reference are equally valid, yet they predict two different, mutually exclusive events. The train is either trapped, or a collision occurs. One of these scenarios must be wrong. How do we resolve this? Einstein's clue suggests that we ignored how the doors receive their signal. To solve the paradox, we must consider the mechanism. A signal must be sent, and it travels at a finite speed, the speed of light. The one rule that changes everything is that the speed of light is constant for all observers. First, let's analyze the mechanism from the tunnel's frame of reference. A button is placed at the exact midpoint of the tunnel. When the front of the train hits it, the button sends out a light signal to both doors, causing them to close. From this view, the doors close at the exact same time. Since the sensor is equidistant from both doors, and the doors are stationary, the light signals arrive simultaneously, trapping the length-contracted train. Now, for the crucial part, the same event, viewed from the train. We are on the train, so the mechanism is moving towards us. The critical rule applies. The light still expands in all directions at speed c from the point where it was emitted. The front door moves towards the signal, so it closes first. The front door rushes toward the point where the signal was emitted, intercepting the light pulse early. The door closes first, long after the nose of the train has passed it. No collision occurs. The back door moves away from the signal, so it closes much later. The back door is receding from the signal's origin point, so the light pulse must travel a greater distance. By the time it arrives, the entire train has passed through the tunnel, and the back door closes safely behind it. The paradox is resolved. Simultaneity is relative. Events that are simultaneous in one frame of reference are not necessarily simultaneous in another. This fundamental principle is called the relativity of simultaneity. This raises a much stranger question. If two events can happen at the same time for one observer but one after the other for another, what does this imply for cause and effect? Could an observer exist for whom you were born first? The resolution to the train paradox opens a door to an even deeper understanding of space-time. The logic of the universe is often stranger than our intuition.